Good morning. Due to campus being closed, I'm going to go over a couple more examples of complex numbers. Examples from 1.3, just because I can't hold office hours today. So I'm going to do a couple of examples, and hopefully this will help you complete your homework. First example I'm going to do is one of these square roots of a negative fraction. So let's get started. First thing we're going to do is we're going to rewrite the square root of negative 50 over 9. We're going to split it into the square root of negative 1 times the square root of 50 over 9. We can do that because the multiplication of the two square roots is equivalent. Then I can go ahead and I can split the square root of 50 over 9 into the square root of 50 over the square root of 9. Now the square root of 9 we can evaluate, which will give us 3. The square root of negative 1 we can evaluate, which will give us I. And we need to do a little bit of side work for the square root of 50. So I'm going to put a little side work cloud over to the side over here. We have 1, 4, 9, 16, 25, 36, 49, 64. 50 lives between 49 and 64. So I'm going to divide 50 by 49, I get a decimal. 50 divided by 36, I get a decimal. 50 divided by 25 gives me a perfect solid 2. So I can rewrite this expression here as I and then square root of 25 times square root of 2, and then evaluate the square root of 9, which is 3. So from there, I can now evaluate the square root of 25. So I have I, square root of 25 is 5, square root of 2, still there, and then all over 3. So this is our answer. Typically when you write this out, you would write it as 5I square root of 2 over 3. So essentially you kind of kick this I into the numerator, because if you can think of it as being I over 1. So if you multiplied that by square root of 5 square root of 2 over 3, we would get 5I square root of 2 over 3. So this is kind of the proper way to write it. It's very likely that this would be an acceptable response as well. All right, so hopefully that one helps you with some of the questions from the homework. Let me go ahead and look. Here. Okay, so the next example I'm going to go over. It's going to be a multiplying problem. So let's say I have 11 plus square root of negative 25 times 2 minus the square root of negative 36. Our first step here is going to be to rewrite these negative square roots, or square roots of negative numbers, in terms of imaginary numbers. So on the side again, square root of negative 25 is the same thing as square root of negative 1 times square root of 25. Square root of 25 is 5, and square root of negative 1 is I. In the same vein, you can do the same work and get that square root of negative 36 equals 6I. So we're going to come back over here and we're going to rewrite these negative square roots of negative numbers as in terms of their imaginary simplifications. So that gives me 11 plus 5I times 2 minus 6I. So that first step is just rewriting those square roots of negative numbers in terms of imaginary numbers. Now we multiply this using essentially the FOIL, distributing twice. So we would get 11 times 2, which is 22, 11 times negative 6i, so that's negative 66i. 5i times 2, so that's plus 10i. And then 5i times negative 6i is negative 30i squared. So we end up combining our middle terms together. So I get 22 minus 56i minus 30i squared. But remember, I squared is just equal to negative 1. So we can rewrite this I squared as negative 1. So we end up getting 22 minus 56i minus 30 times negative 1. Well, negative 30 times negative 1 gives me positive 30. So I have 22 minus 56i plus 30. Now I can combine my constants. So I get 22 plus 30, so that's 52 minus 56i. Okay, so that's an example again where we're multiplying imaginary numbers. Remember, if it looks like this in the beginning, you need to rewrite those square roots of negative numbers in terms of their imaginary representation, and then you multiply this, treating the i's like they are variables, with the caveat on the end that I squared is equal to negative 1, so we can always rewrite this I squared we get as a negative 1, multiply that out, so then we can combine our constant terms. So hopefully that helps as well. I'm going to pause and then start a new video for the dividing.